Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is string to integer conversion, atoi. Let's jump into the problem statement, understand it and start solving. So last time we have solved the partition equal subset problem. You can find it in the list. Let's start with string to integer. Okay, it's not any string to integers problem statement. It has some variation and we have to cover those things as well. Let's go through the problem statement. Implement the myatoi string as function which converts a string to 32-bit signed integer similar to C atoi function. The algorithm for myatoi is as follows. Read in and ignore any leading white spaces. Okay, so we have to ignore all the starting white spaces. Check if the next character, if not already at the end of the string, is negative or positive. Okay. Read the character in if it is either. This determines if the final result is negative or positive respectively. Okay. Assume that the result is positive if neither is present. Okay. So this is same as saying 2 is positive 2 and minus 2 is negative 2. Read in next the characters until the next non-digit character or the end of the input is reached. The rest of the string is ignored. Convert this string, these digits into an integer into 32-bit range. If no digit were read, then the integer is 0. Change the sign as necessary from step 2. Okay. If the integer is out of 32-bit sign integer range, okay, then clamp the integer so that it remains in the range. Specifically, integers less than minus 2 raised to power 31 should be clamped to minus 2 raised to power 31. And integers greater than 2 raised to power 31 minus 1 should be clamped to 2 raised to power 31 minus 1. Return the integer as the final result. Okay. So we have got it, right? Let's see the example. The input is 42, we print 42. Next example, the input is there is a space, then minus 42, we print minus 42. We remove this space, right? Similarly 4193 and then with words we ignore all of this and print 4193. Okay, similarly if it is out of range, we'll present minus 2 raised to power 31 for negative which is outside range, and positive which is outside range will return 2 raised to power 31 minus 1. Okay, so all we are going to check is we are going to check for the leading white spaces, we are going to check for the signs, and then we are going to check for overflow. That's all. It's a very simple problem statement. Let's start coding. Okay, so first let's initialize few of the variables that we need. Initialize variables for one is for result. We need one for sign and also one for index. Why index? So that we can traverse through this given string, right? For this case it is 42, but for other cases it is space 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 negative sign then 4 then 2, right? So let's start. We'll say int result is equal to 0, int sign is equal to 1, that is for positive, int index is equal to 0. So we have initialized the sign as positive for the beginning. Okay, now first we are going to remove the leading white spaces. Ignore the call them leading white spaces. Okay, while index is less than s dot length and s dot caret index is equal to space, right? Then we'll simply ignore, that means we'll move forward our index pointer, index plus plus, right? So that for all these white spaces we'll keep moving the index forward. Similarly we'll check for sign, so either we will get a sign like negative or we'll have no sign and we'll simply be having the integer. Okay, that's why for these cases it's the default +1, for this case it will get changed to -1. Okay, so we'll check for sign. Mention if index is less than s dot length and we have to check, let's check s dot caret index is equal to plus, that is the plus sign it is equal to plus, we need one more, or s dot caret index is equal to minus, right? In either case it's a sign, so we'll simply change the sign to whatever the number is. So sign is equal to s dot caret index. If it is equal to minus, then we will say -1, otherwise we need to 0.1, right? And then we can say index plus plus. Okay, that's it. Lastly, we'll check, we'll start reading the digits of the character, like 4 2. And how do we form a number from this? Let's say we read the first character 4, we keep it in the result 4, and before adding the next character we do result into 10, that is 40 plus 2 42, right? So we can say read in digits until a non-digit character or end of string is reached. Until a non-digit character or end of string. Okay, so we'll say while index is less than s dot length. Now what else we need to check? We need to check character character dot is digit, right? S dot caret index, right? So the index is lesser than the length and it's a digit, then we can say int digit is equal to s dot caret index minus 0. We are removing the ASCII value to convert it into the integer, right? Since this character from this 4 that will come out is character 4, right? We need to create integer out of it, so we are using the ASCII value of 4 and subtracting 0 out of it, just like we used to do for with the ABCD characters, right? We will always subtract a as a character to remove the ASCII value. So let's say, for example, let's say the ASCII value of the character 4 is 104, and we are saying 104 minus 0, and ASCII value of 0 character is 100. So 104 minus 100 would be 4, and we'll get 4 as a digit, right? You can check the ASCII values, it's not that big deal. Okay, and now we'll check for overflow before actually updating them. So we'll say check for overflow before updating the result. Okay, why before? Let me update the result first for everyone to understand. Let's say we are updating the result directly. Update the result. How will we update the result? We'll simply say result is equal to result into 10 into 10. Let's make it more beautiful. Into 10 and then plus digit, right? So that's how we get 4. But similarly, if a number is outside the range of 2 raised to minus 31 or 2 raised to plus 31, we need to check for that, right? So that we don't directly make this result and then there is a inbound circle, right? After this, of course, it will be index plus plus. But before this, we are going to check for the overflow. So we'll check if result is greater than, please pay attention here, integer dot max value, okay, minus digit and this whole divided by 10. So we are checking if we can add this digit as per and create a new result and it will not overflow. So we are checking for the overflow if it happens already. In case it happens, then we'll check for the sign. We'll check what is the sign. Let's say sign is equal to 1. If the sign is equal to 1, that means the overflow is in the positive direction. So we need to return this as the answer, integer dot max value. If not, we need to return the negative side result, integer dot min value, right? If there is no overflow, we'll keep adding the result is equal to result into 10 plus digit. Like in this case 4 would be 0 into 10 0 plus 4 4. Next time we get 2, so 4 into 10 40 plus 2 42, right? And index plus plus, we'll keep moving the index. In the end, we can simply apply the sign whether it's negative or positive and return the index. So we'll say apply the sign to the result and return. So we can say return result into sign. If it's -1, it will be negative. It's +1, it will be same as positive. Let's run it quickly. So you see, it was a very simple problem. We have some typos. Let's see, where did we integer dot max value. Okay, yeah. So as I was saying, the problem is very simple. All we are doing is, first we are removing the white spaces, then we are checking for the sign, that is negative positive, after the white spaces. So whichever is the first character after the white spaces. Okay, like let's say we consider this case, there is no white space, so first loop will not run. The first character is not a sign, so sign will not get changed and it will remain +1, right? And lastly, we are traversing through the digits as long as we reach the as long as either we don't reach the end or we don't reach non-digit character. Like in this case, we'll reach only till 3. After 3 we'll get white space, that will be ignored by this condition. Okay, and then inside this we are checking for the overflow. Otherwise we are simply updating the result as a normal function that we always use. Result is equal to result into 10 plus digit. Okay, that's all, and we have used quite a efficient approach. So overall time complexity must be good. It's 100%. Okay, and yeah, as per the time complexity, since we are traversing the overall string only once, it will be O of n. That's it. So yeah guys, that's all from today's video. If you have anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.